Assalamualaikum dear students, welcome to Learning at Home. I hope you're doing good. Today we are going to learn about Newton's laws of motion. Before starting the video, if you haven't subscribed this channel, please do subscribe and like this video and share as much as you can. Newton's laws of motion explain almost everything about how objects move, stop and react. They were discovered by a scientist named Sir Isaac Newton, and believe it or not, he figured all this out way back in the 1600s. And guess what? We still use these same laws today in science, engineering, sports, and even space travel. By the end of this lesson, you will understand why objects stay still or keep moving unless something stops them, how force, mass, and acceleration are connected, and how every action has a reaction. Yes, like when you hit a ball and feel it hit back. So get ready because after today you will never look at motion the same way again. Newton's first law is called law of inertia. An object at rest will stay at rest and an object in motion will stay in motion unless a force acts on it. This law tells us that things don't just move or stop for no reason. If something is sitting still, it will stay still. If it's moving, it will keep moving at the same speed and in the same direction, unless a force changes that. This tendency to resist change in motion is called inertia. For example, a resting ball. Imagine a soccer ball sitting on a field. If no one touches it, it just stays there, right? It doesn't suddenly roll away on its own. That's because no force is acting on it. It stays at rest. And when a force is applied on the ball, it starts moving. The second example is a moving car. Imagine you are riding in a car and everything is going smoothly. Suddenly, the driver hits the brakes. What happens? Your body moves forward. That's inertia again. Your body wants to keep moving at the same speed the car was moving. But the car stops, so unless your seatbelt stops you, you would keep flying forward. Inertia is why we wear seat belts, to protect us from our own body's motion when the car stops suddenly. Newton's second law, the law of acceleration. Force equals mass times acceleration. F is equal to mass multiply acceleration. This means that if you want to make something speed up, slow down, or change direction, you have to apply a force. And the heavier the object is, the more force it takes to move it. For example, the empty shopping cart. Think about pushing an empty shopping cart at the grocery store. It's super easy to push. Just a little force and it starts rolling fast. That's because it has low mass, so it doesn't need much force to accelerate. Example number 2 is full shopping cart. Now load the cart up with bags of rice, water bottles, and maybe a watermelon or two. Try pushing it now. Not so easy, right? That's because with more mass, you need to apply more force to get it moving at the same speed. The heavier the object, the more effort it takes to change its motion. That's Newton's second law in action. Newton's third law, the action-reaction law. For every action, there is an equal and opposite reaction. This means that anytime you apply a force to something, it pushes back on you with the same amount of force, just in the opposite direction. For example, bat hits the ball. When you swing a baseball bat and hit the bat applies force to the ball. That's the action. But at the same time, the ball applies an equal and opposite force back onto the bat. That's the reaction. That's why your hands sometimes sting after hitting the ball. You are feeling the force coming back at you. Another example is of jumping on a trampoline. When you jump down on a trampoline, you are applying force downward with your body. That's the action. The trampoline pushes you back up with the same force, and that's the reaction. That's why you bounce into the air. Forces always come in pairs. You push on something and it pushes right back on you. Dear students, let's quickly go over all three of Newton's laws. First law, that is inertia. Things stay still or keep moving unless something makes them stop or change. For example, resting ball or sudden car stops. Second law, force is equal to mass multiply acceleration. The more mass an object has, the more force it needs to move. For example, pushing an empty versus full shopping cart. Third law, action-reaction. Every force has an equal and opposite force. For example, bat hitting a ball or jumping on a trampoline.